In our first lesson, we're going to answer the question, how do I compare ratios using tables and graphs? So before we really get into all of this, do you remember what a ratio is? Hopefully you remember that a ratio is just a comparison of two quantities. For example, 3, let's see here. Here we go. 3 to 2, or you can write it with the colon, or maybe you just want to write 3 to 2. So maybe I'm comparing, 3 pencils to 2 pens. I don't know. But that's all a ratio is. Now, what if you have equivalent ratios? Equivalent ratios are ratios that are obviously equivalent. They're equal to each other. So let's see, I've got 3 over 2 as my first ratio. Well, another ratio that's equivalent to that one is 6 over 4. Or maybe 9 over 6. All of these ratios are equal to each other. If you were to take the 6 over 4 and simplify it by dividing by 2, guess what? You'll get 3 over 2. Same thing with 9 over 6. If you divide by 3, you're going to get your 3 over 2 again. All of these ratios are equivalent to each other because they're all going to simplify, or may already be simplified, to 3 to 2. And the last part, can you explain what a proportion is? And, how do you solve one? Well, a proportion is when you have two equivalent ratios, two ratios that are the same, they're equal to each other. And solving a proportion usually means that one part of our ratio is missing, and we have to solve it. You could probably solve it with a factor puzzle. So, for example, if I gave you 3 over 2 inside a factor puzzle, and let's see, maybe I'll have 12 over here, how could I solve this proportion? Right now I have 3 to 2, and that is equivalent to, sorry, I'm trying to make these circles a little bit bigger. Here we go. 3 to 2 is equivalent to 12 to what? Maybe we'll put an X there or something. So I can solve this using a factor puzzle. Of course, 3 would be in common here, this would be 1, this would be 4, this is 2, and 2 times 4 is 8. And that makes sense because 3 over 2 is the same as 12 over 8. Those two ratios are equivalent, they're equal to each other. Watch what happens when you cross multiply. 2 times 12 is 24, 3 times 8 is 24. Those are equivalent ratios, and you can check them by cross multiplication. And we used factor puzzles to solve this proportion. Now, this isn't in your workbook, so don't go looking for it. I have a situation here that involves cherry orange drink. Sue likes to make cherry orange drink. She has a special recipe with the ratio of 5 cups of cherry juice to 4 cups of orange juice. So for Sue's drink, I know I've got cherry juice and I've got orange juice. So I'm going to use C and O. C for cherry, O for orange. And it looks like my basic ratio of cherry juice to orange juice is 5 to 4. Hopefully this is coming back to you. Now that we have ratio tables, we can use our basic ratio to fill in the rest of the ratio table. Like right here, 5 times 2 gives you 10. So I'm going to do 4 times 2 and I'm going to get 8. 5 to 4 is the same as 10 to 8. How about 4 times 5 gives me 20. So I'm going to have to do 5 times 5 and get 25. Or at this one, 5 times 9 gives me 45. So I'm going to have to times by 9 here. 4 times 9 is 36. So all that you're doing here is you're filling in the rest of the ratio table using your factors 5 and 4. 4 times 3 gives you 12. So 5 times 3 gives you 15. And of course you can fill in the rest. This is going to end up being 30, and this one over here is 32. Now I'm going to do the same thing, but this time let's look at Ben's drink. Ben, he also likes to make his cherry orange drink, but he has a different recipe. His recipe is 6 cups of cherry juice to 5 cups of orange juice. So same thing, cherry to orange, and the basic ratio is 6 to 5. So let's see, 5 times 8 gives me 40. 6 times 8, that's 48. 6 times 5 gives me 30, so 5 times 5 is 25. 5 times 2 is 10, so I'm going to times it by 2 over here. 6 times 2 is 12. 6 times 4 is 24, so 5 times 4 is 20, and so on. You can just use your multiplication to figure out the missing numbers. So there is the rest of the ratio tables for Ben, and of course Sue we had at the beginning. Now what we're going to do is we're going to use these ratio tables to answer some questions about, their cherry orange drink recipes. First, can you find a ratio in Sue's table and a ratio in Ben's table that have the same amount of orange juice? So I'm going to look at each one, and I'm going to look at the orange juice column because I'm looking for a column, or I guess a ratio where the orange juice amount is the same. So let's see, looking at orange juice, oh, I see this one here. Do you see how we have 20 here, 20 cups of orange juice? And over here, same thing, we have another 20 cups of orange juice. So I can see that at this point, when in Sue's drink, she has 20 cups of orange juice, and then there's 25 cups of cherry. Whereas with Ben's drink, when he has 20 cups of orange juice, he's only using 24 cups of cherry. So whose drink is more cherry flavored? In this case, it looks like Sue's drink is more cherry flavored because she is using 25 cups of cherry, whereas Ben is using 24 cups. So Sue's drink is a little more cherry flavored. And now let's do the same thing again, but this time, can you find a ratio in Sue's table and in Ben's table where they have the same amount of cherry juice? So now let's look at cherry juice. Let's see, I'm going to look at the C column, and oh, I see this one here, there's a 30 to 24, and this one here, there's a 30 to 25. So both of them, at this point, have 30 cups of cherry juice. Now, when Sue has 30 cups of cherry juice, she has 24 cups of orange juice. And when Ben has 30 cups of cherry juice, he has 25 cups of orange juice. So whose drink is more orange flavored? In this case, it's Ben's. And you can see he's got 25 cups of orange juice when Sue has 24. So Sue's is a little more cherry flavored, Ben's is a little more orange flavored. Now the next thing that I'm going to do is that I'm going to graph these on the coordinate grid. Let me just move this out of the way. Now we may not be able to fit all of them, but we can try and fit some of them. So Sue's drink, let's see, I might start at 5, 4, starting on the cherry side. So over 5, 1, 2, 3, 4, 5, and up 4, 1, 2, 3, 4. It looks like I'm going to have, let's see if I can get my little dot there. There it is. And then we have 10, 8, 6, 7, 8, 9, 10. And 8 would be right about here. And then this is going to keep going. So basically over 1, 2, 3, 4, 5, up 4. Over 1, 2, 3, 4, 5, up 1, 2, 3, 4, and so on and so forth. So you can see that this right here, this blue, it's not perfect, but this is for Sue. Okay? And now I'm going to do the same thing, but this time with Ben's drink. I'm going to graph some of the points for Ben's drink. Maybe I'll use red for Ben. And Ben has 6, 5, so over to 6 and up 5. And then we have, oh, I see 12, 10. I can probably graph that one. So 1, 2, 3, 4, 5, 6, up 1, 1, 2, 3, 4, 5, right about here. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, right about here. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, right about there. And you can see, it's not perfect, but there is Ben's drink. Okay, I probably could have graphed a few more points for Sue. Maybe I'll do that. Hers was over 5 up 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So maybe I'll finish hers. Okay, so now I know that they're very, very close. Both recipes are very, very close. But take a look at the red line. The red line, if you remember, was for Ben. And Ben's red line looks like it's closer to the y-axis, and then it looks like Sue's blue line is closer to the x-axis. So the blue line is more to the right, the red line is more to the left. So I can actually use this graph to prove that Ben's drink is a little more orange flavored because his line is closer to the y-axis where my orange is. And then I can prove that Sue's drink is a little more cherry flavored because her line is closer to the x-axis where cherry is. So here are the takeaways. Just like we can compare fractions using common denominators, we can also compare ratios by finding common values in a table. Or we can even graph those ratios on the coordinate plane. We can compare them by seeing how close they are to the x-axis or maybe how close they are to the y-axis.